friends, welcome you all to Think Max. This is class 11 Max, chapter 1, sets. In this session, we are going to discuss about exercise 1.1, all the questions. First question, which of the following are sets? Justify your answer. First one, the collection of all the months of a year beginning with the letter J. So this is the statement. We have that is the collection of all the months of a year. It should begin with the letter J. So we know there are 12 months in a year. So from the 12 months, we can collect the month which begins with the letter J. So it is well defined. If it is well defined, then it is a set. So from this collection, we can tell the number of months that start with the letter J. That is, in this we have January, June, July, what else? August, September, October, November, December, they don't start with the letter J. So it is well defined. So this first one is a set and it is a set. So in a set, we should have well-defined collection of objects. It should not differ from person to person. So here, only this is fixed. January, June, July are fixed. So it is well-defined collection. So then, the first one is a set. Second one, the collection of 10 most talented writers of India. 10 most talented writers of India. I say this is not well defined. Why? This is because you can say 10 most talented writers. So you can list out some 10 most talented writers on your side. But I can say another 10 most talented writers. Both the list will not be the same. That is, it differs from person to person. So this one differs from person to person. So if it is different from person to person, then it is not a set. So the answer is, it is not a set. Next, third one, a team of 11 best cricket batsmen. So if this is like a statement, here also 10 most talented writers and 11 best cricket batsmen. So you can choose some list of 11 best cricket batsmen. If I choose in my category, I can choose different person. So it differs from person to person. So it is not well defined. So this is not well defined because each person selects some person. So each cricketer will be different. According to each person, he may think that person is that cricket batsman is a best batsman. But what happens? It differs from person to person. So it is not well defined. So if it is not well defined, then we can say it is not a set. So the reason is differs from person to person. Next one, the collection of all boys in your class. So in a class, we can select the boys. Okay. So this is well defined. So the boys can be found out from the class. Okay. So that is well defined. So if it is well defined, then it is a set. We can find the boys in the class. Number of boys in a particular class. So it is well defined and it is a set. That does not differ from person to person. Okay, children. So moving on to the next page. Fifth question, the collection of all natural numbers less than 100. Is it well defined or not? Yes, it is well defined. So our natural number starts with 1. So we can say 1, 2, 3, 4, etc. All the numbers till 99. Okay, less than 100. So counting numbers from 1 to 99, it is fixed. There is no change in it. Okay, so it doesn't differ from person to person. So this is fixed. 1, 2, 3, 4, 5, 6, all counting numbers from 1 to 99 is fixed. So that is, it is well defined. So if it is well defined, then it is a set. Next, sixth question. A collection of novels written by the writer Munshi Premchand. So, this is a particular person, Munshi Premchand. So, can you find the novels written by the writer Munshi Premchand? Yes, we can find it. Will it differ? It will not differ because the writer is a particular person. So, what he has written is well defined. So, we should select the novel which is written by Munshi Premchand, not any other novel. So, it is fixed. So, the novel written by Munshi Premchand. So, it is fixed, that is, it is well defined. So, it is well defined. So, if it is a well defined, that is, we can find the novels written by the writer Munshi Premchand. If it is well defined, then it is a set. Okay. Next question, seventh one, the collection of all even integers. So it is well defined because we can find out all the even integers like 2, 4, 6, 8, and this will not change from person to person. All even integers are same for each person. So it doesn't differ. So if it is not different from person to person, then it is the well-defined collection of sets. That means it is a set. Okay. Next, eighth question. The collection of questions in this chapter. So in a particular chapter, we have to find out the questions. Can you find out? Yes. So in this particular chapter, we can find out what all the questions will be asked in the exam. So there will be some fixed questions, not any other questions that goes away from this chapter. So it is well defined. So we can find the questions in a particular chapter. Then it is well defined. If it is well defined, then it is a set because we can find. So we can find questions in this chapter. Next one, ninth one, a collection of most dangerous animals of the world. Here I say this is not well defined. Why it is not well defined? Because same type of animal. So if we take a tiger, most dangerous. Some tigers will be most dangerous. Sometimes it will not be most dangerous. So it differs from one animal to another animal. So if we take an elephant, yeah, an elephant will be very soft sometimes. Some other elephant, so it will be attacking the human beings. Okay. So it will differ from animal to animal. So we cannot find out which animal is most dangerous. So it will differ from animal to animal. So it is not well defined. So if it is not well defined, then it is not a set. So this is the first question. So the statement is given whether it is set or not. We have to find out whether it is set or not. A set should be a well-defined collection of objects. Well-defined means it should not differ from person to person. Okay. So these are the conditions for a set. Now let us move on to the next question. Second question. Let A is equal to 1, 2, 3, 4, 5, 6. Insert the appropriate symbol. The symbol means belongs to or not belongs to. There is a belongs to symbol and a cut is there. So it is not belongs to in the blank spaces. So this is the set. The set contains the number 1, 2, 3, 4, 5, 6. So belongs to means the particular number 5 should be in the set, should be present in this set. Now it is 5. For the first question, it is 5. Whether 5 is present here? Yes, the 5 is present. If it is present, we have to put the symbol belongs to. So this is belongs to. That is 5 is in the set A. Belongs to means It is present in the set A. So 5 is present in A. So we should write symbolically 5 belongs to A. Okay. Next one, second question 8. Whether 8 is in the set A? No, 8 is not present. So it doesn't belongs to. Doesn't belongs to means put the symbol belongs to and cut. So 8 does not belongs to A. In the same way, 0. Is it 0 here? There is no 0 here. So 0 does not belongs to. Next 4. Yes, 4 is present here. So we can write 4 belongs to. Next take 2. Yes, 2 is present here. So 2 belongs to A. Next 10. Is it 10 here? No, 10 is not present. So it is absent. So 10 does not belongs to A. It's very simple. Okay. Just you have to use the symbol to show whether it is belongs to this particular set or not. Okay, children. So moving on to the third question. Write the following sets in roster form. Okay, what do you mean by roster form? We have to find out what are the elements in this set and write it inside the curly bracket. So first question, A, set of all. So what is the set A? A is equal to set of all x such that x is an integer and what is the condition? Minus 3 less than or equal to x less than 7. So there are two conditions for x. That is x is an integer. What do you mean by integer? Both negative, positive numbers and 0. It is minus 3, minus 2, minus 1, 0, 1, 2, 3, etc. So they are all integers. So these are all integers. In integers, what are the numbers we need? It should be greater than or equal to minus 3. So from minus 3 greater than means these numbers minus 2, minus 1, 0, 1, 2, 3. But it should be less than 7. Less than 7 means it should end with 6. So A contains the numbers greater than or equal to minus 3. So minus 3 is included. Greater than minus 3 is minus 2, minus 1, 0, 1, 2, 3, 4, 5, 6. Because less than 7, not less than or equal to 7. So less than 7, 6 is less than 7. We should stop with it. So it is equal to is not here. So we should not write 7. So with 6, we should stop. So this is the set A. Okay. So next one, capital B. X is a natural number less than 6. What is B? Natural number. Natural numbers means counting numbers. Counting numbers start with the 1. So it less than 6. Less than 6 means 1, 2, 3, 4, 5. Okay. Less than 6. So we should stop with 5. So these are the natural numbers less than 6. Next is third one. C is equal to set of all x such that x is a 2-digit natural number such that the sum of its digits is 8. Okay. So C is the 2-digit natural number. So it's addition. So if you add the 2 digits, its addition should be 8. Okay. So let us start with the tens place with 1. With 1, we have to add 7 to get 8. So 17 is the first 2-digit number and its sum is 8. Sum of the digits is 8. Next, write 2. With 2, we have to add 6. So 26. 26 is the 2-digit number whose sum of its digits is 8. Next 3. With 3 we have to add 5. So 35 is the next 2-digit number. Next write 4. With 4 we have to put one 4 so that 4 plus 4 equal to 8. So 44 is the next 2-digit number. Next 5. With 5, we have to add 3. So 53 is the 2-digit number. With 6, we have to add 2. So 62 is the next 2-digit number. With 7, you have to add 1 to get 8. So 71 is the next two-digit number. Next, if we take 8, 8 plus 0. 8 plus 0 is 8. So 80 is the next two-digit number. So after that, if we put 9, it will be greater than 8. Okay, sum of its digits should be 8. So after that, we will not get 8. Okay, so these are the two-digit number whose sum of its digits is 8. Okay, children, I hope you can understand this. Next, fourth one, d is equal to x such that x is a prime number which is divisor of 60. Okay, it is a prime number. So how to factorize 60? Take 2. It is 30. 2 into 30 is 60. 2 into 15 is 30. And 3 into 5 is 15. So it takes the prime number 2, 3, 5. So D takes the value. Put the curly bracket and write the numbers 2, comma. So separate the elements with the bracket 2, comma, 3, comma, 5. So this is the roster form. So in roster form, you have to write the set name equal to, start with the curly bracket and write the elements, separate the elements using comma and close with the curly bracket. So this is the roster form. Next, E. What is E? Fifth problem. We have to find out the set E. Set E is the set of all letters in the word trigonometry. So here, if it is a word, we have to find out the letters. We should not write the repeating letters. So which letters are repeating here? O is repeated. Next, T. T is also repeated. And R. R is also repeated. Okay. So we have to write the letter only once. So E is equal to set of all T, R, I, G, O, N. Again there is O, it is repeated because it is already written here. So don't write it. So leave O and write M. Next E. Again there is T, it is already written, so don't write it. Next R is here, R is already written, don't write it. Next Y. So this is the set of all letters in the word trigonometry. Okay. The same way, sixth problem, we have to find out the set F. The set of all letters in the word better. So in better, what are the letters? B, E, T. Already T is written, so strike it. E is also there, it is repeated. So we have to write the letter only once. So what are the letters present? B, E, T. Again another T is here. We have written here, so don't write it. E, it is written, so don't write it. Next R. So these are the letters in the word better. Okay, so F takes the values B, E, T, R. So B, E, T, R are the elements of the set capital F. Okay, children, I hope you can understand this problem. So moving on to the fourth problem. Write the following sets in set builder form. So that is, we have to write set of all x such that x. What is the statement for x? So here, how is the set here? It is written as 3 into 1. Next 6. 6 can be written as 3 into 2. 9 can be written as 3 into 3. 12 can be written as 3 into 4. Now this 3 is fixed. Only the second part. 1, 2, 3, 4. So 1, 2, 3, 4 are natural numbers less than or equal to 4. So now how we can write it? So the answer is set of all x such that x will be equal to 3 into natural number. 3n. Okay, 3 into n. So what does n takes the value? N is a natural number and there is a limit. Okay. So n takes the value 1, 2, 3, 4. So that is n is greater than and equal to 1. So from 1, n is greater than or equal to 1 and less than or equal to 4 because n takes the value 1, 2, 3, 4 and n is a natural number and it starts from 1 and ends with 4. So n is greater than or equal to 1 and less than or equal to 4. So this is the set builder form for this. Okay. Next, second question. 2, 4, 8, 16, 32. Now if you look into it, so this is 2. Next one is 4. We can write 2 into 2. If you check the third number, it is not 2 into 3. It is 2 into 2 into 2. So that is 2 is multiplied thrice. So it is in the power form. So first 2 is 2 power 1. Second 2 is 2 power 2. 2 into 2, 4. Third 2 is 2 power 3. 2 power 3 is 8. 16. 16 is nothing but 2 power 4. 2 into 2, it is 4. 4 into 2, 8. 8 into 2, 16. Next 32, it is nothing but 2 power 5. Okay. So it is not like the first problem, multiple of 3. It is nothing but 2 to the power something. So if you check the powers, this 1, 2, 3, 4, 5. So this 2 is fixed. So it is there is change only in the powers. How it changed? 1, 2, 3, 4, 5 are all natural numbers and the condition is it should be greater than and equal to 1 and less than or equal to 5. This is the condition. So we can write the answer as set of all x such that x is equal to 2 power n and this n belongs to the natural number system and it takes the value 1 to 5. So it is n greater than or equal to 1 and less than or equal to 5. This is the set builder form. Next, second question. So just if you check 5, 25, 125, 625. So if you look into it deeply, you can say it is 5 power 1. What is 25? 5 into 5. That is 5 to the power, I'm sorry, 5 to the power 2 is 25. What about 125? With 5 to the power 2, if you multiply 5. So 25 is nothing but 5 into 5 into 5. This is 125. 5 5 is 25. 25 into 5 is 125. So it is 5 cube. Next, 625. So with this 125, if you multiply with 5, you will get 625. So 5 into 5, 25. 25 into 5, 6, 125. 125 into 5 is 625. So it is nothing but 5 to the power 4. Now how will you write the solution? So the solution for this is nothing but this 5 is fixed. So the answer is set of all x such that x is equal to 5 to the power n. What are the values it takes? And n is a natural number. 1, 2, 3, 4 is a natural number and it takes the value 1 to 4. So it is greater than or equal to 1 and less than or equal to 4. So it is very simple. Okay. Next one, fourth question. Set of all 2, 4, 6. So there are multiples of 2. So we can write this as 2 into 1, 2 into 2, 2 into 3, etc. Now this 2 is fixed. Only the second half is 1, 2, 3. It goes on like this. So it is counting numbers 1, 2, 3, 4, 5, 6. So it is natural number. There is no n. So we can write it as set of all x such that x is equal to 2n and n belongs to the natural number. There is no limit for this. Okay. So we can write n belongs to capital N. Or otherwise, you can write set of all x such that x is an 2, 4, 6 are all even natural numbers. So these are all even numbers. There is no negative sign. So it is even natural number. So x, set of all x such that x is an even natural number. You can write in two forms. Both are right. Okay. Next, fifth one. 1, 4, 9, etc. up to 100. So if you check this, they are all square numbers. So it is 1 square, 4 is nothing but 2 square, and 9 is nothing but 3 square, and 100 is nothing but 10 square. That is 1, 2, 3. So this power 2 is fixed. So this is fixed. Power 2 is fixed. Only the number in the base is changing. How it is changing? 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So they are all natural numbers that begins with 1 and ends with 10. So how do you write the answer? It's nothing but set of all x such that x equal to n square. Okay, this power 2 is fixed and n is the natural number starting from 1 to 10. So n belongs to natural number system capital N. And what are the conditions? N should be greater than or equal to 1 and it should be less than or equal to 10 because N takes the value 1 to 10. So it is greater than or equal to 1 and less than or equal to 10. Okay, children? So you can understand this fourth problem. So moving on to the next question, fifth one. List all the elements of the following sets. So there is no set builder form or roster form. We have to find out just the elements of the set. So what are the elements present here? What is given? A is equal to set of all x such that x is an odd natural number. So what are the odd natural numbers? So odd natural numbers are nothing but 1, 3, 5, 7, etc. So these are all odd natural numbers. They are asking only about the elements, not about the set. So no need to write the curly brackets. Just write the elements. So these are the elements. Now B part. What is B? Second question. B is equal to set of all x such that x is an integer. For that, what is the condition? X lies between minus 1 by 2 and 9 by 2. So x lies between minus 1 by 2 and 9 by 2 and x is an integer. So x is an integer means it takes the value minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, etc. So this is the integer. Okay. Now in this integer, what is the condition? The condition is minus 1 by 2 less than x. So what is minus 1 by 2? It is nothing but minus 0.5. What is 9 by 2? It is nothing but 4.5. So between minus 0.5 and 4.5, we have to find out the integers. So between negative 0.5. So negative 0.5 lies between minus 1 and 0. So it should be greater than minus 0.5. So greater than minus 0.5 is 0. So the elements are, so we will write the answer. The elements are 0, 1, 2, 3 and it should be less than 9 by 2. Less than 4.5. So after 4 we have 5. So 4.5 lies in between this. So it should be less than 4.5. Then what is the integer there? It is 4. So the elements are 0, 1, 2, 3, 4. Okay, children, you understand? So let me draw the scale and show you. So we have the integers minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5. Now what is the limit? The limit is minus 1 by 2, which is nothing but minus 0.5. So this is the minus 0.5. Next limit is, upper limit is 9 by 2. 9 by 2 is nothing but 4.5. So this is the 4.5. So in between, what are the integers are there? 0, 1, 2, 3, 4. So these are the integers that lies between minus 0.5 and 4.5. This is the answer. Okay. Now third question, C. C is equal to set of all x such that x is an integer and x square is less than or equal to 4. Okay. So here x square is less than or equal to 4. It is also an integer. So integer means the same way we have minus 4, minus 3, minus 2, minus 1. So what are the integers it takes? X is an integer means we can say minus 3, minus 2, minus 1, 0, 1, 2, 3, etc. So this is an integer. So x is an integer. So capital Z denotes the integer. So this is an integer. What is the next condition? X square should be less than or equal to 4. So for this what we get? What is minus 3 square? Minus 3 square is 9. Minus 2 whole square, it is 4. Next, minus 1 whole square, it is 1. 0 square is equal to 0. Next, 1 square equal to 1. And 2 square, 4. 3 square, 9. Now, what is the condition? X square should be less than or equal to 4. So, x square is here 9. So, it doesn't comes. Less than or equal to 4? Yes. This is less than or equal to 4. And 1 is less than or equal to 4. 0 is less than or equal to 4. 1 is less than or equal to 4. 2 square is 4, less than or equal to 4. 3 square is 9. It is not less than or equal to 4. So what are the values it takes? Minus 2, minus 1. So what are the integers are there? Minus 2, minus 1, 0, 1, 2. So the answer is minus 2, minus 1, 0, 1, 2. So if we take this integer and find out the squares, its square answer will be less than or equal to 4. Okay, children? Here you can understand this problem. So moving on to the next page, we have the fourth question for the fifth problem. What is it? D is equal to set of all x such that x is a letter in the word lawyer. So what are the letters are here? L, O, Y, A. Again L is repeated. So we should not write it. So the answer is L, O, Y, A. So these are the elements present in this set. Next E. Fifth question. Set of all x. X is a month of a year not having 31 days. So not having 31 days. We have 12 months. In that, what months that doesn't have 31 days? January has 31 days. February has 28 or 29 days. So we will get February. Next, March, it has 31 days. April has 30 days. Next, May has 31. June has 30 days. So July has 31 days. Also August is also has 31 days. So go to September. September has 30 days and October has 31. Next, November. November has 30 days. So you can find out this using holding your finger. So if you hold your finger, you can see the bends ups and downs in the bone part. So if it is bending down, then it is 30 days. Okay, children? These are things you know from the kids stage. Next, sixth question. Capital F. It is nothing but set of all x such that x is a consonant. Consonant in the English alphabet which precedes K. Precedes K means before K. Before K, what are the consonants? So what are the consonants? First we know vowels. What are vowels? Vowels is nothing but A, E, I, O, U. So these are all vowels. Remaining are all consonants. So what are the consonants which precedes K? That is before K. A. First alphabet is A. A is a vowel. Next one, B is a consonant, C is a consonant, D is a consonant, E is a vowel, F is a consonant, G is a consonant, H is a consonant. Next one is I is a vowel. So we should not write. Next J is a consonant. Next is K. So before K, these are all consonants in the English alphabet. Okay, children? I hope you can understand the fifth problem. So moving on to the last problem in the next page. Match each of the set on the left in the roster form with the same set on the right described in set builder form. So here this is roster form. We have to match the roster form with the set builder form. So what we can do, we can check the set builder form. In the set builder form, some statements and conditions will be given. So first statement, set of all x such that x is a prime number and a divisor of 6. X should be a prime number. So first one, here 1 is not prime. So we cannot take this. Next here, 2, 3. 2 and 3 is a prime number. Is it a divisor of 6? Yes. 2 divides 6. Also 3 divides 6. So A is for second one. So we can write here 2. Okay. Next one. Set of all B question. Set of all x such that x is an odd natural number less than 10. So it is odd natural number. So if you take the first one, here 2 is not odd. So this is not possible. Already second one is matched. Here there are letters. So we cannot take this. What about the fourth one? 1, 3, 5, 7, 9. They are all odd natural number less than 10. So this is for the B part. So we can write it as 4. Next, C question. Set of all x such that x is a natural number and divisor of 6. So it is a divisor of 6 and it should be a natural number. So let us take, there are only two options here. So this is letter we cannot take. Now take this 1, 2, 3, 6. 1 divides 6. 2 divides 6. 3 divides 6 and 6 divides 6. So this is for C. We can write here as 1. Okay, children? I hope you can understand. Because the set here is 1, 2, 3, 6. 6 is divisible by 1. And 6 is divisible by 2. 6 is divisible by 3. 6 is divisible by 6. Okay. So we can say 1, 2, 3, 6 is a natural number and divisor of 6. Next, what is D? This is a letter of the word mathematics. Yes. M-A-T-H-E-I-C-S. Or it is a letter of the word mathematics. So this is 3. Okay, children. I hope you can understand this exercise. If you have any doubts, you can come at me with this exercise. 1.1 is complete. Okay. Thank you. If you are able to follow my videos, just show your support by sharing among your friends and subscribe to this channel. And without fail, just click the bell button so that you get the notification whenever I upload my videos. Thank you.